Hey everybody, we're back. TechBiz tutorial. This, I think, may possibly be the last Arduino Zumo bot program that I'm going to do for a tutorial for a while. Let's recap what we've learned. We've learned how to adjust the motors for the Zumo bot. We've learned how to program the buttons, use the buzzer, use the proximity sensors, use the border detectors. I'm sure there's things that I'm forgetting, but we've learned a lot of things with this. The LED lights, the LCD display, all that kind of cool stuff. And now we're going to put it all together to make a Zumo fighting robot. So without your knowledge, I've been training you to become ultimate robot fighting machine programmers, and now you can take all these tools that we've gone through and you can put it together to make a robot. That they have these things called Zumo competitions, and you have the two robots and they are not allowed to go outside of a border. We've learned that. They need to also be able to force out other robots from the playing area, from the ring. Okay, so you want to push the other robots past the border, and we've kind of been learning that with the proximity sensors, and with some ingenuity and creativity you can find ways to put all those things together into one program. I put together just a real simple one here, and I'll show you how I did mine. You'll be able to come up with one that's a lot better, but this is real basic. Alright, so include Zumo 32U4.h because we need that ZumoBot library. The define QTR threshold. In some of our tutorials we use 700. 800 was working a little bit better for me. Maybe it was because the lighting was changing when I was practicing on the surface. And remember, the QTR threshold is for our border detection. Alright, so if we're, and this is with a dark surface with light lines. Alright, then on here we have, and I put in notes to myself to remind me, 400 is max speed for the motors. So reverse speed is going to be 200, turn speed's 200, forward speed's 200, reverse duration is 200, that's a time. Turn duration is 300, that's a time. And then I'm putting on something here that says RAM speed max 350, RAM speed min negative 200. And that might be a typo. I don't know why I put negative 200 on there. I would think that 200 would be better, but I'm just going to leave it like this. I'm tired and I probably made a mistake, and we'll see how it works when I run the program. Alright, instances for button, motor, proc sensor, buzzer, LCD, and line sensor classes. So we're combining everything we've learned in all our tutorials now, minus the serial input and output. Zumo 32 U4 button A, we need for the button A. Motors for the motors. Line sensors to define line sensors. Proximity sensors will be called proc sensors. Buzzer will be called buzzer. LCD will be called LCD. We have those on there. Activating the line sensors, we're going to define num_sensors 3 and unsigned integer line sensor values num_sensors. That's from the tutorial we did with the line sensor program. So I'm just showing you how to fit all these things together to make the bare minimum ZumoBot program. Alright, now we want to wait for the button A to be pressed. I thought it would be cool to play the charge song and then wait 3 seconds, then initialize the sensors. So void setup, we're going to lcd.clear. We're going to go to line 0, column 0, and say press A, and then we're going to go to the next line down to fight. Alright, and then button A dot wait for button. So it's going to wait for us to press the button. It's going to clear the screen, and it's going to print the word charge on the LCD screen. And then Zumo 32U4 buzzer is going to play. And remember all our stuff from our buzzer tutorial when we're going beats per minute for the tempo and all that. And this is just as close as I could get to charge. Alright, so you can maybe come up with a better song. This is what I came up with. So we'll play the song through the buzzer. It's going to delay for the 3 seconds. And notice I didn't program to wait for this to finish like we did with our previous buzzer program. I'm having that 3-second start as this is playing, so it's kind of like we don't have to wait for the song to play and then wait 3 seconds. Okay, then we're going to initialize the line sensors, and we're going to initialize the proximity sensors. Now we're ready for the void loop. Collects input from the sensors, so it's going to be checking line sensors.read, line sensor values, and prox sensors.read, and integer left sensor is equal to prox sensors counts left with left LEDs. You'll recognize this just straight out from our other proximity sensor program that we did before, if you've been following along with these. Integer center left sensor proximity sensor counts from left LEDs. And then we have the center right sensor counts with right LEDs, and integer right sensor is equal to prox sensors counts right with right LEDs. Alright, so we have those things on there. Pretty easy. And then we have if we detect the line. Alright, so this is going through with our line sensor values. If it's less than the QTR threshold, then motor.set speed, it's going to reverse. It's going to turn for a defined amount that we listed above, and it's going to set the speeds to turn. So one's going to be going turn speed, the other's going negative turn speed. So this particular one, in this instance, is turning to the right because the right one's going backwards, the left one's going forward. And it's going to delay turn duration, and then it's going to go forward speed. If the sensor detects the line on the other side, it's going to back up and turn. So here we just did the same thing as above, but we are flipping it around so it turns the other way. So in this case, it would, if it sees it on the other side, it's going to reverse for the defined time that we listed above, and the set speeds are going to then turn the object to the left because the left one's going negative, which means it's going backwards, and the right motor is going forward, so it would be turning left. Motor's set speeds are then put to forward speed, so it's going to be driving forward. Now if the center sensor detects an object, we want it to ram the object, because if there is something in the ring, we assume it's the other robot because it's a Zumo fighting ring. So here's one else if. Now here's another else if. Else if computer right sensor is greater than 4. This is from our prox sensor tutorial before. Then we're going to have, okay, if it's greater than 4, center left sensor is greater than 4, motors are going to set speed to ram speed max and ram speed max. If sensors detect an object off-centered, so I was right. Let me highlight this here, okay? And then, well, I'll just remember where it's at. Let me go back up to the top here. Sorry to do this to you. Yeah, ram speed min, I want it to be 200. So that was a typo. My bad. I must have bumped that. Funny when I was plugging everything back in. Okay, so anyway, let me go back down here now to our void loop. Okay, so if the object senses it in the middle, you know it's going to ram the object. Now here, if the right sensor is greater than the left sensor, okay, then what we want to do is we want the left motor to ram speed at the max, which was the higher number than the ram speed of the min. because then it's going to veer and hopefully swerve into the object. Okay. Now else if it's the right sensor is less than or if the right sensor is less than the left sensor, then the left motor is going to be going faster than the regular speed but slower than the max speed of the other. Gosh, man, I'm just all over the place bumping these keyboards. I apologize. Okay, so you'll have the motor swerving to the other way to hit the object. That way it makes it be a little bit better of instead of just always hitting the object straight on. If it sees it's more to the left, maybe it's going to try to swerve and hit it more dead on, giving it more of a chance to push the other robot out of the ring. Okay, now if the robot doesn't see a line or it doesn't see a border, and it doesn't see an object in front of it, and if it doesn't see an object more to the left or more to the right, then what's it going to do? Well, the Zumo bot's just going to be driving forward at forward speed. So our robot is going to have these choices, or these instances as it's going to start. It's driving along, it's going to see a border. Oh, if I see the border, I'm going to back up, turn, and then go forward again. Or it's going to see an object, and if it sees the object, then it's going to hit it straight on. Or if it sees the object at a offset angle, it's going to swerve and hit into the object until that object isn't there anymore. So there we have our first basic Zumo robot. Now I bumped the keyboard like 3 times when I was typing this stuff and going through it with you, so who knows what's going to happen. But I'm going to save this progress. I'm going to upload it to the robot, and let's see if this thing actually works. Here we are. Time to try this thing out. It says press A to fight. We should push this button. It should say charge and have a song that sounds a little bit like charge. Nice. Alright, the object is driving around, and you can see its speed's a little bit inconsistent because I think it's seeing the wall and it's also seeing me, but hear that difference of that when the object is driving, and hear how it speeds up. We'll see if it'll push the box out. Yeah, good job. It won. All right. So there we have our Zumo robot. It's detecting the borders. It's detecting objects, and it's swerving at them. It played the song. The button worked to get it started, all that stuff. So I think we had a pretty successful test, and now you can do some Arduino code to program your own Zumo bot. See if you get your own Zumo bot and get somebody else who has one, you can kind of see who comes up with the better code and have your own Friday Night Fights Zumo style. Thanks for watching, and hopefully you liked it and learned something, and you'll watch some of our other tutorials. See you later.